So basically today we start the sheet number 6. This is sectional view of the solid. Okay. So first there will be in section, basically there will be two types of sectional view. One is called full sectional view, one is the half sectional view. Suppose this is a object, you see this is your object. If you cut by this object like this, so this is the full sectional. Okay. So you cut the object on the full section. So if you see the suppose this is a cylinder. In this cylinder, if we cut, you see a line. In this line, if we cut the cylinder, so this is basically the full section. Clear? And what is the half section? Half section, suppose if we cut like this, first up to the half section. So this is the portion of the half section. Okay. And similarly, if you quadrant section, 1/4 section, different types of section will be there. So this is the half section and full section. Now, basically, when we cut the section, this cutting line will be chain thin line, and the two edges will be the thick. Chain thin line, two edges will be the thick. And if you see, when suppose this will be cut the material, so what will happen? Here the material will be the removed. Okay, here the material will be the removed. So at this portion we get the hatching line. Okay, when there will be a hatching line, so this is called basically the material removed from this section. Clear? So now, so if we see, so first there will be a cylinder. Suppose this will be the cylinder, it will be position will be like this. Now we cut according to this. So then the cutting portion will be the cylinder. So if you see from the top, this is called top sectional view. If you see from the front, this is called front sectional view. And if you from the side, this is called side sectional view. Here your side will be like this. You see like this type of things. Okay. And if we see the perpendicular of the cutting plane, means suppose this is your cutting plane. So in suppose for this cylinder, if you see from the top, you see a circle. But if we see from the perpendicular of the cutting plane, then this will be the ellipse. You see, this will be the ellipse. Yeah. So this view is called true sectional view. Means true sectional view means you see, means your eye position will be the perpendicular of this cutting plane, not from the top. Perpendicular means here. So you see the actual ellipse view. Yeah. So this is the, so one view will be the front sectional view, top sectional view, side sectional, and another called is true sectional view. So for drawing the true sectional view, basically the top right corner there will be space required. Okay. So first we start from the first problem. Now a cylinder of 40 mm diameter, 60 mm long, 60 mm height, and having axis vertical. Axis vertical means it is rest on HP. So it's already in projection of the solid. We know if the position will be there. So its front view will be the rectangle and top view will be the circle. So first we draw the front view and top view. And remember, at the top left corner, you have to require the space. So first we draw XY line. And it is rest on HP, so its top view will be the circle and front view will be a rectangle. First draw the center line. So first we draw the circle of diameter 40 millimeter and draw the center line. Okay. Now each point we draw the projection. And here also draw the projection. So this height will be the from the XY line will be the 60 millimeter because it will be a 60 millimeter height and axis vertical. So first this is the front view and top view. Okay, and here also we divide the circle 8 equal parts. Why we divide? Because if you see, so before this what we'll do, so now it is cut by a cutting plane perpendicular to the VP, inclined 45 degree to the HP, intersecting the axis 35 millimeter above the base. Okay, so now it will be cut by a cutting plane. So if you see, suppose now you see the line, or if you see the line, now this is 45 degree line. So first we draw the center line. So the always the cutting line position about the center axis. Always means here this is 45 degree to the HP, intersecting the axis 35 millimeter above the base. So on the axis this is above the 35 millimeter. So first we draw the axis. So this is the chain thin line. So first we draw the axis. Now from the XY line we measure from this point we measure 35 millimeter. So this will be suppose, so total height will be 50 millimeter. So here this is 35 millimeter. So at this point first we draw a 45 degree angle, and this point height will be the 35 millimeter. So this is basically the chain thin line thick at two edges. Okay, so now what we'll do, here we draw. So this is the, this height will be the from the axis, this is 35 millimeter. Okay, and this height will be the 50 millimeter. So from 35 millimeter we mark the point on the axis and draw a 45 degree line. Okay, so now the what will be the your actual front view. So this is the sectional front view, and what will be the red color? This will be the dark in this. Then and here this will be the chain thin line. And here the end position will be the thick, and here also end position will be the thick. So this is the sectional front view, and sectional top view also a circle.
Sir?
Now we dark the circle. So this is the sectional top view. Now what we do? Basically, for now you able to draw the true sectional view. For drawing the true sectional view, you see this will be the ellipse. So for ellipse, you have to require more number of points. Here you get only 2 points or 3 points. Okay, but for ellipse, you have to require the more number of points. Otherwise, it is difficult to draw the ellipse. So for what we'll do, we divide the circle 8 or 12 equal parts. For simplicity, we choose 8 equal parts the circle. So for we divide the 8 equal parts, so each line will be the 45 degree. So first we draw the 8 equal parts, and from each point it will be the same line, and we extend up to this projection. So this will be the 8 equal parts we divide. So now each point we project up to this. And here also these 2 points will be same line up to this line. And now we give the name. Okay. So here this is A, B, C, D, E, F, this will be the G, and this will be the H. And here only we give the name on the section point, because you have to concern about the section, not the other part. Okay. In previously, when we do the solid position, there will be 2 parts. There will be upper part we give the name, and lower part we give the name. But here we only the section point we give the name. So this will, so for this reason, this will be the point. So this will be the A dash. This point will be the B dash and H dash. This point will be the C dash and G dash. This point will be the D dash and F dash. And this one will be the E dash. Okay. Now we draw the true sectional view. So for drawing the true sectional view, first what we'll do, each point of the front sectional view, you have to draw a line perpendicular of this cutting plane. So here the cutting plane angle 45 degree. So if we draw a another line 45 degree with the horizontal, so we get the perpendicular line. So here we draw another horizontal perpendicular line like this. Now similarly in this point, so each point we draw the perpendicular line. So each point we draw a perpendicular line. Now here any arbitrary distance you take such a way that when you draw the two sectional view, this does not merge with the main figure, this main front view figure. So some arbitrary distance we take a line parallel to this A dash to E dash line, means 45 degree. Here you draw a 45 degree with the horizontal, and here also a line 45 degree with the horizontal. So that's the correct line.
Sir, এই ডিসটেন্সটা কত হবে?
So first we choose this axis. This is parallel to A dash to E dash and give the name A to E. So here we give the name. This will be the A1 and this will be the E1. Means you just project this top view here in this line. So how can you do this? So here each point A, B, C, D, E, F, G, H, you have to project at this line. So how can you do this? How can you project at this line? So first A and E will be the extreme left point. Here, so you have to measure all the point about this center axis AE. First you project the AE here. So this is A1, E1 in this 45 degree angle. Now each point from this AE distance, vertical distance you have to measure. So first by compass from this point to this point H, measure it. So B and H and it will be this line. So suppose this will be the cut it here, and B also cut it. Because this is a circle, the vertical distance from this central line to H and B both are same. Similarly, from vertical distance C and G, this is the radius of the circle. So by compass take this vertical distance, and this will be the C and this will be the G. Then similarly D and F. So then D, then F, then E. So from this we can write this is B1, then C1, then D1, E1. This will be the F1, then G1, then H1. So in this way, so here maximum point C and G. So means C1 point does not match here. So you in this way you choose the arbitrary distance from this A dash E dash to A1 E1. Now we join by ellipse. By using the French curve or by freehand. What will be that? So you see this type of ellipse. Means if you see the true sectional view, it will be see like this. You see this ellipse will be used shown to you from the true sectional view. Okay, this true sectional view basically this ellipse. I mean basically this is the actual cutting during the cutting view. Okay, so this is called true sectional view. Now we draw the side sectional view. For side sectional view, procedure will be remain same, similar to solid projection. First we draw the 45 degree line, and each point HF will be same line, AE will be the same line, B and D will be the same line, and C will be the same. C will be another line. Now each point we draw a vertical line. Here also vertical line. One minute. This line not draw properly. And here each point we draw a intersection point. So basically, if you see, this is very small will be there, but actual size this will be circle must be come. There will be circle because this is 45-degree cutting plane. So it will be from the side view, it will be as a circle, it will be comes. Okay. And if you give you all of you find out how to go to the point, I just draw the figure. Basically, it will be circle will become. I will check it. Here it is not actually draw by dimension, so the figure will be first we draw this line, then this line. And it will becomes as a circle. If you see, it will become must become as a circle. Here the angle is not drawing properly, so it will become as a circle. Okay. The side view comes as a circle. Basically, it will becomes like this. This type of figure it will become when you draw the actual dimension. So this is the circle, and it will becomes like that. It will becomes like that. When you draw, this is the side view. Here the dimension and as well as the actual figure dimension is different. And when you give the and another important part, because you see this top portion, the material will be removed, so you have to draw the hatching line. So how can you draw the hatching line? The gap between two hatching line will be 1.5 to 2 millimeter or 1 to 2 millimeter, and this must be angle will be 45 degree of this axis. So here axis AE, so this must be 45 degree in this way, and the gap between two will be 1 to 2 millimeter, not much more than. This will be hatching line, means your material will be removed from the solid body. Here material removed. Similarly here also. Here you see the 45 degree. So means if you draw the vertical line, this will be the 45 degree with the axis. Similarly here, this also 45 degree in this way. This will be the circle basically. So in this circle, this will be the 45 degree. Here the gap is not proper, so you have to maintain the gap 1 millimeter each. At 1 millimeter each, you can maintain the gap for hatching line, drawing the hatching line. This is basically the side view. Here this is not drawing properly as per dimension, so this must be circle come. Approximately circle or perfectly circle may become. perfectly circle maybe because this is 45 degree, so this is the perfectly circle come. So this is the problem number one. And when you give the dimension, so first here from this draw the extension line, here also draw the extension line, then so this will be the 40 is given, so this will be the 40 and from this point to this point, so this C dash and G dash, this will be the 35 and from this line, this will be the 60. This is the one dimension. So this is the true sectional view. This is the top sectional view, red part, and this is the top sectional view. This is the front sectional view. This is the top sectional, the side view.
এসজে বলছি এই কাটিং প্লেনের অ্যাঙ্গেলটা দেখাতে হবে না?
হ্যাঁ দেবো, না দেখালেও চলবে, কিছু অসুবিধা নেই।
কেন একটা পার্টিকুলার অ্যাঙ্গেল তো বলে দিয়েছিল বোধহয়।
বলে দিয়েছে। এখানে এরকম ভাবে দিয়ে দিতে পারো তোমরা, এই যে লাইনটা এঁকেছো এরকম ভাবে, এটা এরকম ভাবে আছে, এই লাইনটা তুমি এরকম ভাবে তুমি এটা করে দিবে। So all of you first extend this line and you show the angle like this. So this will be the 45 degree. So draw the extend the chain thin line thick at two edges here and here. This will be the 45 degree. So in this way you can show the angle of the cutting plane. So now it starts problem number 2. A square prism with 40 mm edge, axis 56 mm long, rests on its base on HP, with its side equally inclined to the VP. A concentric circular axis hole of 24 mm diameter is cut through the prism. The prism is cut by a cutting plane perpendicular to the VP and inclined at 60 degree to the HP. Bisect the axis. Draw the front view, sectional top view, sectional side view, and true shape of the section. So basically, in this problem, there will be a square prism. So in square prism, so all of you see square prism. Basically, in square prism, first all of you tell me what will be the difference between square prism and cube. First, you tell me what will be the difference between square prism and a cube.
Sir, a cube contain all the 6 faces square, and a square prism base is only square.
Okay. Can we tell cube is a square prism?
No, sir.
Cube is a one type of square prism where the side will be same as the height will be the same as the side of the prism. Clear? This is special type of square prism cube is. Okay. So means all square prism not a cube, but all cube is a one type of square prism. So this is the basic difference will be the cube and square prism. So here it is in your problem, this will be the square prism and it will be equal, one side will be equal inclined to the VP, means the position will be like this. Okay. And so this is the 40 meter edge and axis 56 centimeter long, based on HP. So this will be the position basically. You see these two edges and equally inclined to the VP. If this will be the VP, So these two surfaces will be equally inclined to the VP. Means these two surfaces equally inclined to the VP. Means you have to draw this line, and this line will be 45 degree. So it will be positioned like this. Next, a concentric circular axis hole 24 mm diameter is cut to the pinion. So inside this, a concentric circular hole will be there. Okay. So first we draw the top view, front view for this position. So what we'll do, first we draw a square. So here, first we draw a line 45 degree with this, and here also draw a 45 degree line with this. By compass take is 40 millimeter, cut it here, and also cut it. So from this again, you have to draw, cut it here and cut it. So from this you first do a square. So this angle will be the 45 degree. And so what will be the then front view? Front view, if you see the front view, basically in front view, if the position will be like this, so you see these two edges, and this means this line, and these three line you can see. So what we'll do for this, each point we draw the projection line. And this height will be the 56 millimeter from the XY. So, and inside there will be a circle. This diameter will be 24 meters. So this is the center point. We draw a small circle. So inside there will be a circle. Now, and this circle will be through hole. So at front view, if you see the front view, you do not see the circle from the front view. So this will be the hidden. Okay. So for this, what we'll do, we draw a hidden line. So from this point, and this will be must be hidden line. This should be the dotted line. So this should be the dotted line because it is hidden. Now the prism is cut by a cutting plane perpendicular to the VP inclined 60 degree to the HP. So it will be cutting a cutting plane like this, 60 degree. So then what will be the figure? It will be the cutting plane. Now it will be like the position will be like this. It will be like this. Now if you see the front, better. If you see the front, you see this type of figure. Means this part, this portion, and at the top view, you see this small portion will be there. Okay, this is not the cut. So for this, what we'll do? From these 2 points, we draw the projection. So then and this will be the chain. So this is the front sectional, and front top view will be like this. And there will be circle also. So this is the top sectional view. Now we do the true sectional view. So for true sectional view, first we step by step. First we do the prism part. Then we do the whole cylinder. Okay. So for this, what we will do? Same way. Here the angle 60 degree. So if we draw a 30 degree line, we get the 90 degree of this cutting plane. And here the cutting plane position, this is the bisect the axis. So this will the total height will be the 56. So from the center to this point will be 28 millimeters. Now here we draw a 30-degree line. And first we give the name. So this will be the A, B, C, D, E, and F. Because here section, this point not in section part, so we do not consider the name here at this point. Okay. So this will be the A dash and B dash. This point will be the C dash and F dash. C dash and F dash. So from this also there will be a line, and this point will be D dash and E dash. This line is wrong. So here we draw from C dash and F dash line, another line will be 30 degree. Now this is the, so now same way here this will be the center line. So first we draw the center line like this, parallel to the A dash to D dash E dash, this parallel line. And here A and from the center line measure by compass A and B. So suppose this will be, so this will be the A, this will be the B. By compass take the vertical distance of the point A and B. So this will be the A, this will be the B. Similarly from this point measure C and F. So this will be the C and this will be the F. Then D and E. So D and E, so this will be the D, this will be the E. And joined by straight line. So this is about the two sections of the prism. Now we do the circle. For circle, similarly, here we do same way 8 equal parts, similar to previous problem, and each point draw the projection line up to the section line. Okay. And give the name. Suppose this is 1, 2, 3, 4, 5, should be 6, 7, 8. So this point will be the 1 dash. This will be the 2 dash, 2 dash and 8 dash. This will C dash F dash again. This will be 3 and 7 dash, and 4 and 6 and 5. So again, each point we draw a similar to previous one. And from the center line again, so this will be the 1, then 2, then 3, 4, 5, again 6, 7, 8. So if we join like this, So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the ellipse, similar to previous problem. Okay. So this is the true sectional view. Now we draw the side sectional view. For side sectional view, when we draw, you see the line of A, D, E, C, B very lightly different. Okay, A and D and B and D, A and E. You see, and maybe it will be merged depending upon your drawing. Okay, so A, E, both are. So you have to make main principle. You have to each point you have to draw the projection line. So how can you get it? First you draw a 45-degree line. Then you draw from the F. Here you see A in very small according to my figure, but if you figure it may be in same line, or maybe A line will be lower, E line will be upper, depend upon the figure. Similarly, D point also. Let's see. Again, first we draw the prism. So only there will be 3 lines. And this will be. So first mark the point. First A double dash. So A double dash will be this point. This will be A double dash. Then B. What will be point line will be not drawn. Then B double dash will be this point. Then C will be there. Then D, this point. Then E, then F. So now if we join, and this portion also you can see. This is not the section part. Means if you see the side view, so if you see from the side view, basically your this part, this part means this part and this part you can see. Now we do the circle. So for circle, what we'll do? For circle, this will be the line. This line should be already drawn. This point, this point, and this point. Now here, this is the point. Then 8 and 4 will be this point. Then each point of the circle also you have to draw the here. Then again 2 and 4. Very carefully drawing because the all lines should be very merge each other. So very first you draw the prism section, then draw the circle. Then 3. And mark the point. Point marking is very, very important. Otherwise, you do not find out the points. So here, what will be the points? Suppose this will be the 1 dash, then 2 dash and 8 dash. So this will be the 2 dash and 8 dash. Then C dash, F dash as well 3 dash and 7 dash. So this is 3 dash and 7 dash. Then this point will be 4 dash and 6 dash. 4 dash and 6 dash. And this will be the 5 dash. So for 5, this point will be the one. So this will be the 5 double dash. And this will be the 1 double dash. Then 2, so this is 2 point will be there. Then 2 and 4 will be same line, so this will be the 2. Double dash. 4 double dash will be the 4 double dash. 1 minute. 1 to 3. So this will be the 2 double dash. This point will be the 3. Then again 4 double dash. This 5. Then this will be the 6. This point will be the 7. And this point will be the 8. So this will be ellipse comes like that. It will be like this. Basically, this will becomes the actual figure. It will become like this type of things. Like this. More it becomes like this type of things comes. In front view, inside view, this types of figure it will becomes. And when you give the, then what will be the and hatching line? So in hatching line, when you draw the hatching line, so here only this part is not section part. So hatching line starting from this and circle, if in the circle whole section there will be no material removed. So in circle section there will be no hatching. Okay. Similarly here also, when you draw here, so this is the 60 degree. So you have to draw line 90 degree. So how can you draw? In this line you have to draw a partially 90 degree, 60 degree. So if we draw a line horizontal in the horizontal 30 degree, so not horizontal 30 degree. So because this is 60 degree, so you have to draw by 2 set square, you have to draw 45 degree line here with respect to this line. And the gap between two hatching line will be 1 millimeter. And similarly here also. For two sectional view, it is difficult to draw because this is 60 degree line. You have to require two set square for drawing the 45 degree. So this is the true sectional view. This is the top section, front sectional view. This is the top sectional. This is the side sectional view. And when you give the dimensions, so for giving the dimensions, first this height will be given. So directly you can get it. This height. This height will be the 56. And this will be the, from this line, this will be the bisect. So this will be the 28. Okay. Here, so any line, this edge will be the square. This is given 40 millimeter. And for circle, from this point, draw a vertical line. From this point, draw a vertical line. Very lightly draw. And then here you write 24. And this angle will be given 60. So now problem number 3. A hexagonal pyramid of base 30 millimeter side having axis 70 millimeter long. A hexagonal pyramid of base 30 millimeter side having axis 70 millimeter long, resting on its base on HP with two edges parallel to the VP. Okay. So in hexagonal pyramid, so we already there will be two positions of the hexagon. One will be this type of hexagon, and another one will be this type of hexagon. Now here it is tell that two edges parallel to the VP means then the figure is not this one. This is the perpendicular to the HP, and when it is parallel to the VP, now these two edges will be parallel to the VP. Means in top view, we will see the hexagon this way. Okay, clear the. So first we draw a hexagon with 30 millimeter sides, then join the diagonal and we get the center point. From the center point and from each point we draw the projection. Okay, each point we draw the projection line up to the XY line, and from the center line we draw a line, and basically up to the 7, and from the XY this height will be the 70 millimeter. This point to this point 70 millimeter. Then we so from this is basically the center line, and then each point we join from this apex point. We join apex point. Okay, and also this line also, this is the solid line because one edge will be there. If you see the one edge will be there. So this is not the center line, this is the solid line. Okay, and this is the XY line. Okay. Now it is cut by a cutting plane perpendicular to the VP, inclined at 45 to the HP, intersecting the axis, distance 25 millimeter above the base. Now, so first we mark a point 25 millimeter. On this point we draw a line 45 degree, chain thin line, thick at two edges. So first we draw this line, okay, and this angle will be the 45 degree with the XY line. Then we just darken it from the chain thin line and thick at two edges. Okay, now so this will be the section, this part, this one, and this one. So this will be the section, this part, this one. So this part will be the front view. Okay, front sectional view. Now from the top view, each point, so this point, and this 4 point, we draw a vertical line. So first we draw a vertical line, then another vertical line, another vertical line, another vertical line. Okay, now what will be the points? Points basically, if you see, so this will be the point, this will be the point, this will be the point, this one, and this one. Okay, and this one also. Now if we join this, now we join. So first we darken it. Then join with this, then this. And also hexagon, this part will be removed. Okay, so here this part will be there from the top, then this part will be there, this small part will be there, this will be there, this one will be there, and this point also there, small part. So this will be your section. Clear? Clear? So this is the top sectional view, this is the front sectional view. And if we give the name, so this is suppose 1, 2. If we give the name only the section, 3, 4, 5, 6, and 7. So this is this point will be the 1 dash and 2 dash, 3 and 7 same point, 3 dash, 7 dash, 4 and 6 will be this point, 4 dash, days, and this will be the 5 days. Okay. Now we draw the true sectional view. So what we'll do for true sectional view? Each point, draw a perpendicular line. So this is 45 degree. So means in this angle, if we draw a 45-degree line, we get a perpendicular. And here also draw a line parallel to 45 degree. Okay. Now first 1 and 2 point we mark it. Okay. So from this is the basically this line will be the central line. The line, horizontal line in the point 5. Okay. So what we will do? So this first from this line vertical distance from 1 and 2. So suppose this will be the 1 and this will be the 2. Then 3 and 7. So this will be the 3. Same way we can find out. This is the 7. By compass you get the measurement. 4 and 6. So this will be the 4 and this will be the 6. And this point will be the 5. Now if we join it, so first 1 with 2, then 7, then 2 with 3, then 7 with 6, 3 with 4, then 5. So this is the true sectional view. Okay. Now what we'll do? Side view. Okay. For side view, here we draw a 45-degree line. Okay. Now first what we'll do? This line and we just extend this center line. So this line. Up to this we draw. Okay. And from the 5, we draw a vertical line and extend it. And also we draw a horizontal line. Now from this point, first we join this. Means first we side view we draw it. One minute, এটা wrong হয়েছে। You have to draw from this line, not circle line. And Now join this. Okay. Now each point we draw the projection line. Means the section must be inside it. Okay. So firstly, each point we draw the horizontal line. Okay. Now from first we draw a 7 line. And 3 line. And 2. And then 1. Okay. Now if you mark the point and if we draw, so this point will be the 5 point, 5 double dash. If we firstly mark the point, so this will be the 5 double dash. Then 1 will be this point, is the 1 double dash, and 2 will be this point, 3 will be this point. You see, this will be must be marked. The 3 will be in this plane. 3 and 4 you will see. So this will be the 4 will be here. This is the 4 double dash. Then 5, this point will be 6 double dash, and this will be the 7 double dash. And if we join this, so 5 with 6, then 4, it will be like this, comes like this. And this part will also be there. Okay, and now we do the hatching line. Hatching line, this will be very easy. This is 45 degree with the this part only, not this small part. With this the section will be. Similarly here, this part only. And here also, this is basically 45 degrees, so this is vertical line. Now we give the dimension. First, this height will be, it is given 70, and first we draw the extension line. Very lightly, first we draw the line from this. This is 25. And it should be 30. Okay. So this is the problem. So this is the front view, this is the top sectional view, this is a true sectional view, this is the side sectional view. And also this angle will be 45 degree. So see the problem number 4. A cone of base 76 mm diameter and axis 80 mm long is resting on its base on HP. It is cut by a cutting plane perpendicular to the VP and inclined at angle 48 to the HP intersect axis 40 mm above the base. So this is basically the cone. So first cone will be there. Okay. So the base will be 76 mm and the height of the cone will be 80 mm. Okay. Now it is cut of a cutting plane from the base center line, above the center line from the base, the height will be 45 mm. So if you cut it, so you will see this type of here. Okay. And in two sectional view, you see this is a ellipse type things. Okay. Okay. And side view, you will see, if you see side view, it will be like this. Okay, clear? So first we draw the front view and top view. So first we draw the XY line. first we draw the, because it is a cone, we get and here we draw the first center line. Okay. Toward the center point. And from this, we draw the axis line first. And join this. So this is the front view and this is the top view. Yeah. So now, and this basically so this is the chain thin line, this is the center line we draw. Okay. Now, what we'll do first, we divide the circle 8 equal parts, because otherwise the ellipse you have to draw, it is difficult to find out. So for this reason, we divide the circle 8 equal parts. Okay. By using 45 set square, you divide circle 8 equal parts. And you just extend this line up to this. And join this. This is required because if you see the section part, this will be ellipse. So you have to require more number of points to draw the ellipse. Okay. So for this reason, we divide the circle 8 equal parts. And similarly for these 8 parts, we also draw the line from the top view. Sorry, front view. Now in this center line, it is cut by a cutting plane perpendicular to the VP and inclined at angle 45 to the HP internal axis 40 mm above the base. So from this base, we mark a point 45 mm. Total height will be the 80 mm long. So this is 45 mm. So this height will be the 45 millimeter. Okay, and we draw a line 45
From XY plane, sir.
from XY. From XY, the height will be the 45. From XY, we measure
Okay,
45.
sir.
From XY, we measure 45 millimeter height and mark the point. On this point, we draw a line 45 degree because it is given 45 degree with the HP. Okay. So first we draw the so this is the thick at two edges. So this is the front sectional view. Okay, and we inside the line we do not draw the darken it because it is the imaginary line. But if you see, suppose this is there, so you see this one edge, and for simplicity, what we'll do, we get two line also in. Means here we draw another line, means two view we adjust. We divide the circle 8 equal parts. So from this point another line, from this point another line. Okay. So basically, when you front view, you see this one edge and another edge. This will be a cutting section. Clear? Now, what we'll do for this? Each point, similarly, similar to previous one, each point we draw the vertical projection line. If you see the actual figure, basically this point, this line will be outside of this line. Comes. Okay. From each point. Here it is not given the dimension wise. So this. So what will be the points? So this will be the point. This will be the point. This will be the point. This one, and this point. Okay. Now if we join this, it will be like comes like this. Okay. And also So this should be the top sectional view. Okay. And one minute. I'll just okay. So we get the points. Okay. But if we want to get point on the center line, suppose this is one point will be this one, another point is this one, this point, this point, this point, and this point. Okay, so if we want to point, suppose if you see the figure, okay, suppose you see, if you see, your figure will be like this. You see, now you get this point, these 2 points, but in center point, in center line, you do not get these 2 points. How can you get it? So if you see from the top, the radius from the center of this both side will be same. Clear? So means from this point to this up to if you project this point in the slant height, because you actual figure you always get on the slant height, means your this point when you see from the front view, these 2 points will be the same view. Clear? Now if we project on the if we just rotate it on the slant height, so what will you get? This project, this point you can get. Okay, but if you see from the front, you both point you do not get. So from the top view, how can you get it? What we'll do? We just project the point on the in the top view. Sorry, in the front view, we just project the point in about this like this. So here, these 2 points in this point and in this point, these 2 points we just project on the about this slant height, any one slant height, and the radius of this section will be remain same. So from the center to distance, this distance is equal to same, means if you this point will be same point if you see from the front, but if we project the point on the slant height, so what will happen? This the radius from this both sides will be remain same. So what will we get? We get this radius from this point to this point. First we draw a horizontal line up to the slant height, then you measure this radius, you just this center point, it will be cut it here and cut it here. The radius will be from this point to this point, the horizontal distance. Okay, now we join this. Okay, so this is the top. In this way you get these 2 points about the central axis. So this is the 1 dash. This is if we give the name 1 2 3 4 5 6 7 8. So this is 1 dash, then 2 dash 8 dash, 3 dash 7 dash, 4 dash 6 dash, and this will be the 5 dash. Now we draw the two sectional view. Now in two sectional view, this is angle will be the 45 degree. So again draw a 45 degree line here. With the horizontal line, draw the 45 degree line in each point. First we draw a parallel line. Okay, and from one will be the, so this is the one, from the one will be 1, then 2 and 8, so this is the maximum height, so this is 8, this is the 2, then 3, then 7, then 4 and 3 is 6, this is 4, this is 6, and 5 will be on this point. Okay, now if we join this, it comes like this. If we mark the point, it will comes like this. So this is 2, this is 3. This is 1, this is 2, this is 3, 4, 5, 6, 7. Now same way, draw the side view first. So first we draw from this point. And from the side. Okay, so from this up to the XY line we draw. Now I will join this, and each point, if you join 8, 7, 6, 5, 4, 3, and here also each point if you draw a line, okay. And here also 8 point, it will, the figure will be, if you see the figure, it will be comes, I do not draw the other 2, 3, 4. If you draw each line and if you draw the figure, it will be comes like this. Like this. It comes like this. And this will be like this type of figure. And you have to hatch it. I'll show the main figure. and we give the hatching. So this will be the 45. So this is the vertical line again. Okay, and here this part only. And this part only. Okay, and when you give the dimensions, so this height will be the height given 80 millimeter. And from this will be the given 45 millimeter. Okay. If we draw from this, some gap from this. It will be the 76. And this angle will be the 45 degree. So this is the two sectional view, front sectional view, top sectional view, and side sectional